Rotational motion. What is rotational motion? So it happens in various places, like when anything rotates about some axis. So let this object is rotating about an axis, about this axis, let's say. So what happened in this case? So this is basically a three-dimensional object. So there is infinite number of particles all over this body. So rotating about this axis. This is called axis of rotation. So let's say this particle here. So when this object is rotating, so this point particle in this object will move in this circle, move in this circle, move in this circle, and another particle, let's say here, it is here, it will also rotate with the same rotational speed through this circle, the and the center of the circle will be at this point, and center of this circle will be in this point. So this is P1, let's say, and this is say, P2 particle. And we can see that while rotating this object, the both of these particles will rotate in a circle, and both of the circle will be in some particular plane. This is in one plane and this is in another plane, perpendicular to this axis of rotation. So all the particles will move in a circle, and the center of those circles lies on the axis of this rotation. And maybe the particles are in different plane, since this object is a three-dimensional object. Okay, and while rotating, this particle covers a angle. So let's say this is uh, initially this is at this point, and after some time it goes here in this point. After some time, let's say after some time delta t, it goes from P1 to P1 dash, and it covers a angle delta theta. Then we define the angular 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 velocity. So angular velocity is equal to, we define the angles covered with respect to time. So the distance, angular distance covered with time. The ratio of angular distance divided by time taken is called angular velocity. This is the average angular velocity, and it is denoted by omega ab. Since the object is rotating, all the particles of this object, three-dimensional object, will rotate with the same angular velocity. All the particles will cover equal angle with in equal time. So angular speed of all those particles rotating with this axis of rotation, about this axis of rotation, will have the same angular speed omega ab, delta theta divided by delta t. This is the average angular velocity. And angular velocity is a vector which is depends. So angular velocity is a vector quantity, and its direction is along the axis of rotation. its direction is along the axis of rotation. So it it follows right hand, right hand, thumb rule. For clockwise direction, angular velocity is downward. So if the object is rotating in this way, angular velocity will be upward. This vector will be in upside. This anti-clockwise. For clockwise rotation, angular velocity will be in downward direction. If this object is rotating with a constant angular speed, then this is constant. If it is rotating in a different rate, that means it is covering a particular angle in some time and a different particular angle in the another same time. That means in equal interval it is rotating different angle. Then there will be there will be a there will be instantaneous angular velocity. Instantaneous angular velocity omega is equal to, if a very less angle is covering in very small time, then you can take limit delta t tends to 0 d theta by delta theta by delta t is equal to d theta by dt, and this is an vector. The angle will be taken also as a vector quantity because clockwise direction angle is taken negative, and the in anti-clockwise direction angle theta vector is taken as this is positive, and for this rotation theta is taken as negative. This omega is taken as positive. This omega is taken as negative. Clear? So this direction is given by right hand thumb rule. Right hand thumb rule. So instantaneous angular velocity will be found as d theta by dt. Theta is the angle covered in time, in some time. So if delta t tends to 0, that means for instant, this average angular velocity will be instantaneous angular velocity. If angular velocity is constant, then it is called uniform rotational motion. If it is different, it is called non-uniform rotational motion. Now we'll find the let's discuss what is the SI unit of SI unit SI unit of angular velocity. Since this is theta, angle is in theta is in radian, and time is in second. So angular velocity unit is radian per second. So relation between angular velocity and linear velocity of the particle. Let us assume that the same object is rotating about an axis, the object is rotating, and this is the origin of the coordinates. And here particle P is rotating, Q1 rotating in some circle, and let us say this is O, this is C, this is P, vector in this direction, in this direction. This is the radius. This is the radius of this circle. Here let's say, and this particle is rotating in this direction, that is counterclockwise direction. And the linear speed, linear velocity of the particle will be along the tangent of this circle, so in this direction. Whereas that omega is in the direction upward, and this B is in the plane of this circle and tangent to this circle. Radius of the circle is CP. Then what you can write, so this angular velocity and linear velocity are perpendicular to each other. Now what we do, since this omega vector, that means angular velocity vector, is perpendicular, is along the axis of rotation, and what we do, let us take this particle here, and this is origin of the coordinate system, and this particle is rotating in this circle of radius a small r vector, and this is a small r, and from the origin this point lies at a distance of, at a position vector r, r vector. So what we do, we multiply this omega with r vector, capital R vector. So omega multiplied by capital R vector. And we know from this triangle, this R vector is equal to OC vector and CP vector. This OC vector is along the axis of rotation, and CP vector is equal to R vector. So if we put here this value, OC vector plus R vector, omega vector, so omega vector into OC vector plus omega plus R vector. Now this OC vector omega vector in the same direction, so their angle will be 0 degree, and this is omega OC sin theta, sin 0 degree. So sin 0 degree means 0. That means this term will be 0 plus omega cross R vector. So we get is omega cross R vector. But the omega cross R vector is a vector which is perpendicular to both omega vector and R vector. So we take this vector is equal to linear velocity vector of the particle. Therefore, magnitude is equal to omega r. B is equal to omega r. Angle between omega and r is 90 degrees. So B is equal to omega r. This is the relation between linear velocity and angular velocity. Similarly, you can write in the other way as the particle is at a distance of r from the origin of the circle, center of the circle, then linear velocity is equal to v is equal to you can write circumference of the circle divided by time taken. Circumference means 2 pi r, time taken is t. 2 pi by t we can write vector 2 pi by t, angle divided by time we can write as angular speed, average angular speed. This is r, so we can get the v is equal to omega r. For the direction, for the direction of v, we have to write in vector form v is equal to omega cross r. In vector form we can write this. So in this way also we can rewrite the relation. Here you have to take this omega as average angular speed. Okay, so this was the relations between linear velocity and angular velocity for a rotating object.